My name is Gage Reitzel, and you're watching Your Brain and Sleep. First, we will answer the question, what is sleep? Then we will progress into understanding the sleep stages and sleep cycle. Next, we will proceed to the physiological regulation of sleep and explore some contemporary research and applications, followed by supplemental resources. So what is sleep? Well, sleep is described as an innate natural behavior that is periodic, that is to say cyclical, where our nervous system is relatively inactive and our conscious is suspended. But how does it work? Well, there are different stages of sleep, and typically we like to differentiate the difference between light sleep and deep sleep, where we'll generally characterize theta waves, spindles, and the K complex as light sleep, where the delta waves are more of the deep sleep that will occur. REM happens to be a special case that the EEG patterns resemble the patient being awake while they are in fact asleep. It's also where most dreaming occurs. And an acronym to be able to remember these are TSKDDTB, or the Sleepy Kids Don't Dance to Bono. So in understanding the sleep cycle and that there are different stages of sleep that occur, we can see that the cycle of sleep happens anywhere between 90 to 120 minutes, but there will be multiple sleep cycles per night. But how do we fall asleep? Well, there are three primary factors that go into whether or not we are able to fall asleep. There are homeostatic factors or balancing factors, which typically revolve around our hunger, our thirst, whether we're tired or not. Then there are allosteric factors, which are stress factors. For instance, if you're under a lot of pressure at school or a lot of pressure at work, or if a traumatic life event has happened, it's possible for allosteric factors to actually outcompete homeostatic factors, thus keeping you up. And then there are circadian factors, or the time of day factors, that sort of remind us to stay awake during the day and to sleep at night. And if these factors align, then our preoptic neurons become active, suppressing the activity of our arousal neurons, and we're able to fall asleep. But what actually happens when we are asleep? And this will be taking primarily a close look into slow wave sleep. So the ventrolateral preoptic area, or the VLPOA, are a group of inhibitory GABAergic neurons in the preoptic area. If you recall that GABA is a neurotransmitter that is almost a universal inhibitor, just as glutamate is universally used for exciting. And the primary purpose of these sort of collective neurons are to suppress alertness and behavioral arousal. But there are multiple different neurotransmitters that are at play amid these complex systems. For instance, adenosine suppresses arousal and promotes sleep. One interesting note about adenosine is that caffeine competes for the same receptors, so it's possible that if you're able to drink multiple cups of coffee before you would otherwise go to bed, you are actually in a way disrupting some of these other factors and able to keep you awake. Then if we move into the pons, where we have acetylcholine that deals with motivation, arousal, attention, learning, and memory, along with norepinephrine that deals with vigilance. Next, in the Ralphii nuclei, we have serotonin that modulates mood and cognition, along with many other factors. Histamines in the hypothalamus, while a part of the immune system, are also responsible for drowsiness. Think if you've ever taken the antihistamine Benadryl, that you can feel very sleepy afterwards. And then we have orexin, which is used for arousal, wakefulness, and appetite. Orexinergic neurons in the lateral hypothalamus can also be used to keep you awake in terms when you have a high level of motivation. But then sort of going from deep sleep into REM, One thing that is really interesting is we see a lot of blood flow to the visual association cortex, but very low levels of blood flow in the primary visual cortex and the prefrontal cortex. And this is very interesting when you consider that REM is the state in which dreams occur. We see that the serotonin levels lower and stabilize as the acetylcholine levels rise. Why might this be the case? Sort of give you a few seconds to pause the video and think. Well, if you recall the role of acetylcholine as being a part of memory, there are very compelling hypotheses that would seem to suggest that as this neurotransmitter increases in their firing rates while you are asleep, you could get something that can be pulled from your daily life, despite the suspension of consciousness and its radical interpretation. So this table is in our textbook. It does a very nice job summarizing the different chemicals and the accompanying brain regions, along with the transitional levels between the flip-flop of when we are awake and when we are asleep, and as well as differentiating when we are in slow wave sleep, SWS, or REM sleep, rapid eye movement. So in getting into contemporary research here, there's a team of about 20 scientists in Brazil who stumbled upon the plant Annona vipratorum, and they're exploring some of the effects on the GABAergic and serotogenic systems, which of course we have covered the roles of what GABA and serotonin are, so it seems to make quite a lot of sense when looking for anticonvulsants, sedatives, and antidepressants. And what they found is that this plant works on multiple pathways and influences different receptor subtypes, and that the EEG patterns behave closer to if a patient were asleep, where the subjects are more relaxed, less anxious, hence the sort of sedative nature. And they were able to perform this on mice, and they're in the process of exploring a more effective drug delivery system. So while it saddens me to say, at least for now, Inception is probably not real, and it is, for the moment, not possible, given the film's inaccuracies. A couple of supplemental resources that I accessed in the making of this here presentation, along with for my own personal study habits that I've found to work really well, are John Green's To Sleep, Prehance to Dream, Crash Course Psychology number 9, as well as sort of tearing through the NIH Brain Basics. They have a large series, and understanding sleep was very helpful as well. And of course, recognizing that we are amid a pandemic and that there are unforeseen stressors which may arise, Headspace is a great resource for stress and sleep management that I highly recommend. Thank you for listening to my presentation.